Look at that flame. It looks alive, doesn't it? But look closer. It's dying. It's gasping for air in a steel prison designed to choke it. You know this feeling. You paid thousands for this appliance. You split the wood, stacked it, hauled it. And yet, the room is still cold, the glass is dirty, and outside, your chimney is pumping out thick, gray smoke. That's money. That's heat. That's your hard work, literally vanishing into the sky. We've been told that this is just how it is. That wood heat is messy. That it's inefficient. That the only way to fix it is to buy a newer, more expensive, more regulated machine. But what if I told you that 80 years ago, there was a way to burn wood that was so clean, so hot, and so efficient that it actually frightened the establishment? A design that didn't just burn the wood, it burned the smoke itself. And then, one day, it disappeared. This isn't a conspiracy theory about aliens. It's a story about physics, about greed, and about a very specific geometry of fire that we have collectively forgotten. For the past 30 minutes, I've been sitting in front of a stove I built for less than $50. Outside, it's 10 degrees. Inside, I'm sweating. And if you walk outside and look at my chimney, you won't see smoke. You'll see a heat shimmer. The secret isn't expensive technology. It's not a catalytic converter. It's not a computer-controlled fan. The secret is a specific, counterintuitive way of arranging the fire, a method that was quietly phased out of building codes and manufacturers' catalogs because it worked too well. Today, we are going to reverse engineer the lost art of the inverted vortex. I'm going to show you why your modern stove is lying to you, and then, I'm going to give you the blueprint to turn your inefficient fireplace into a blast furnace using nothing but cheap materials you can find at a hardware store. Let's look at the numbers. The average household in a cold climate spends between $1,500 and $2,500 a year on heating. If you use wood, you're trading your time. But here is the statistic that will keep you up tonight. A standard wood stove loses 60% to 70% of the potential energy in the wood. That is inefficiency on a criminal scale. Imagine buying a gallon of milk, pouring 70% of it on the ground, and then drinking the rest. That is what you are doing every time you light a fire. But it's worse than just wasting money. That waste creates creosote. That black, sticky tar that lines your chimney, that is unburned fuel. It is also highly explosive. Every year, thousands of house fires start because we are burning wood wrong. We are trained to think smoke is normal. Smoke is waste. Smoke is failure. If you can see smoke leaving your chimney, you are doing it wrong. You are essentially sending your checkbook up the flue. So, how did we try to fix this? The industry decided to treat the symptom, not the disease. They introduced airtight stoves. They put catalytic converters in them, like a car. They tried to strangle the fire to make it last longer. They told us, control the air, limit the oxygen, slow the burn. This is the fundamental lie. You cannot starve a fire into efficiency. By choking the flame, you lower the temperature. When you lower the temperature, you stop burning the gases in the smoke. The smoke escapes, cools down, and turns into creosote. The contrarian truth, and this is backed by physics but ignored by marketing departments, is that to burn clean, you need more turbulence, not less. We need to stop treating fire like a tame pet and start treating it like a jet engine. We need the flame to spin. We need it to be so hot that it consumes its own waste. Let's peel back the layers. Layer 1, the wood gases. When wood heats up, it doesn't just turn into ash. First, it releases gas. Methane, hydrogen, carbon monoxide. This is actually where most of the heat energy lives, not in the charcoal, but in the invisible smoke. If your stove is cold, these gases escape. Layer 2, the ignition temperature. To burn those gases, you need temperatures above 1,100 degrees Fahrenheit. Most steel stoves hover around 400 or 500 degrees because the steel absorbs the heat and radiates it away too fast. The metal is literally stealing the energy needed to clean the smoke. Layer 3, the missing geometry. So how do we get it that hot? How do we hit 1,100 degrees without melting the stove? We need to insulate the fire from itself. We need to reflect the heat back into the flame, not out into the room immediately. This is where the illegal design comes in. The design that was phased out wasn't a metal box. It was a masonry core. It was a specific internal shape called the bell. But you can't sell a brick shape for $4,000. You can only sell cast iron. So, the industry moved away from masonry internals. The solution? We are going to bring the masonry back, but we're going to hide it inside the steel stove you already own. Here it is, the solution that feels too simple to be true. We are going to build what I call the thermal brick vortex. This is a retrofit you can do in 20 minutes. It costs about $30. It requires 0 power tools. The materials: you need standard fire bricks, not the decorative ones, the dense, heavy ones. They cost about $1.50 each at a hardware store. You need 6 of them. The setup. Step 1. Clear your stove. Step 2. Take 2 bricks and stand them vertically on the left and right sides of the firebox, about 2 inches away from the steel wall. Step 3. Lay 2 bricks flat on the bottom, creating a floor. Step 4. This is the critical part. Take the remaining 2 bricks and place them at a 45-degree angle at the back, creating a curved ramp. The science. By lining the cold steel with these bricks, you are creating an insulated chamber. The steel can no longer suck the heat away from the fire immediately. The temperature inside the core skyrockets. But the magic is in the back bricks. By angling them, you force the rising flames and gases to compress and spin. This creates a vortex. This vortex traps the unburned gases, keeps them in the hot zone longer, and ignites them. You are literally turning your smoke into fire. Cost comparison. A new high-efficiency catalytic stove, $3,500. This brick modification, $9. The brick modification actually outperforms the catalytic stove because there is no sensor to fail and no honeycomb to clog with ash. When you light this, the glass will stay clean. The heat output will change from a shortwave radiant heat that burns your face but leaves your back cold, to a longwave deep heat that penetrates the room. This isn't new. In the 18th century, Count Rumford redesigned the fireplace to reflect heat back into the room using specific angled bricks. The Russians had the Russian stove, a massive masonry heater that burned so hot and clean you could hold your hand in the exhaust stream. But in the 1970s and 80s, during the energy crisis, the world wanted fast, cheap, factory-made heat. We abandoned the masonry expertise of the past for the convenience of stamped steel. We traded efficiency for portability. We traded physics for marketing. The ban on these designs wasn't a literal law saying don't use bricks. It was a building code shift that prioritized factory-certified clearances over thermal mass. Insurance companies got nervous about DIY modifications. And so, the knowledge was lost to the average homeowner. So, why doesn't the stove manufacturer sell you a stove with this brick lining already inside? Because this brick lining lasts forever. The stove industry relies on the replacement cycle. They rely on you buying the gasket kits, the catalytic elements, the replacement baffle plates, and eventually, the whole new stove every 10 years. Fire bricks don't break. They don't have moving parts. They don't need software updates. There is no recurring revenue in a $9 solution. Furthermore, this design shifts the power back to you. Once you realize that you can manipulate the fire using simple geometry, you stop fearing the cold, and you stop depending on the grid. You become self-reliant. And a self-reliant consumer is the worst customer for a corporation trying to sell you a smart wood stove for $6,000. Adopting this method requires a small shift in behavior. You have to stop building teepee fires and start building top-down fires. You load the wood, then the kindling on top. This engages the vortex immediately. You have to accept that the stove might look smaller on the inside with the bricks. But remember, the volume of the firebox doesn't matter. The surface area of the combustion does. You are trading cubic inches for temperature. Once you make this shift, you will notice the silence. The roar of the stove will drop to a hum. The draft will become smooth and steady. Here is the realization. For years, we thought the problem was the wood. It's too wet, we said. Or it's the wrong species. Then we thought the problem was the stove. It's too old. It's not EPA certified. But the problem was neither. The problem was the containment. We were trying to hold fire in a metal box, unaware that the metal itself was the enemy of the heat. We were trying to warm our homes by starving the very source of that warmth. The illegal design is simply the realization that fire needs a womb, not a cage. By adding those 6 bricks, you aren't just warming your house. You are reclaiming a lost technology. You are telling the utility companies, the manufacturers, and the regulators that you don't need their permission to be warm. If you try this brick modification, I want you to do one thing. Take a picture of your chimney while the fire is roaring. If you see no smoke, just a heat wave, post it in the comments. And more importantly, calculate how much would you save this winter. I suspect the number will surprise you. Stay warm. Stay curious.